Okay, in this video we're looking at the 2020 multiple choice questions in the tech-free section of the Mathematical Methods external exam. I'll talk about multiple choice strategy and exam strategy in another video. For now, we're just going to go through the solutions and I'll give you my thoughts. So question one, we've got two functions on this graph. We've got e to the x and x squared minus 1. Those are shown. And they ask for the area of the shaded section bounded by these graphs between the lines of x equals 0 and x equals 1. So we're going to be doing the two different integrals, and we're going to be subtracting them. All you have to do is figure out which one is the higher up function, which one is more positive. And if we're looking here, I can see that this function here is an exponential function, whereas the other function is a quadratic because it has the smiley face, whereas the other one just tapers off. So we're going to have the green one being x squared minus 1 and e to the x being the yellow one, which means when we do the subtraction, the yellow one comes first. So in terms of actually solving, you can go ahead and just do your integration, your mathematics. So we're going to have the integral between 0 and 1 of e to the x dx, and we're going to be subtracting from that the integral from 0 to 1 of x squared minus 1 dx. That's just going to be e to the x between 0 and 1, and we're going to subtract from that x cubed on 3 minus x between 0 and 1. So this one up here is going to be e to the 1 minus e to the 0, and then we're going to subtract, and I'm going to use brackets for this part so I don't make any errors. We're going to have 1 substituted in, so that's going to be 1 cubed on 3, which is just a third. Take 1. And when I substitute 0 into those x values, they're just going to end up being 0 anyway, so I'm just going to leave it like this. E to the 1 is just e to the 0 is just 1, so minus 1. And then we're going to be subtracting 1/3 minus 1, which is going to be minus 2/3. So the subtraction I'm going to start again there. If I'm taking away a negative, I'm going to be adding it on. So it's going to be minus 1 plus 2/3, which is going to equal e minus 1/3, which gives us the answer of D. So if you're not great with integration and substitution and algebra and stuff, that one might take you longer than 1 minute. But it's worthwhile doing it just to make sure you get it right. Some of them take a little bit of time, some of them don't. Answer D. Question 2. We've got another integral here. Now, in the scope of the course, we don't have a skill to integrate a fraction like this. So we're going to have to split it up into two different fractions and then integrate it. So I can separate this fraction into e to the x on e to the x, which is just going to be 1, but I'll write it like this for now. And then we're going to have, I won't write dx yet, and I'm going to add on 1 over e to the x. Now that's going to simplify down into the integral, that's dx, the integral of 1 plus e to the negative x dx, using our index laws, which is going to be, if I'm integrating 1 with respect to x, it just ends up being x. E to the negative x, you divide by the derivative of the power, which is negative 1. So we're going to have minus e to the negative x plus c. And that's going to be A. Cool, there is an answer for that. That's A. So we have question 2 done. Much less than 1 minute, which is nice. All right, question 3. We've got the integral, again, another integral. So I'm just going to leave the 2 out the front. And then when we take the integral of this function, we have to do the chain rule, like the reverse chain rule. So we're going to raise the power and divide by it. So that's going to be 4x plus 6, and we're going to raise that to the power of 4 and divide by that new power. But we also have to divide by the derivative of the inside function. This is the reverse chain rule. So we're also going to be dividing by, so multiplying on the denominator, dividing by 4. So that's going to be 16 there, and that's going to be plus c. So we're going to have on the denominator 16, right? These two 4s multiply to 16. 2 over 16 is going to cancel out into being 1 over 8. And so my answer is going to be 4x plus 6 to the 4 on 8 plus c, which is D. 4x to the 6 plus 4 on 8 plus c. All right, cool. Moving on. Question 4. So 3 integrals in a row, which is a bit annoying, but it's fine. So question 4. Pulse rates of adult men are approximately normally distributed with a mean of 70. So I'm going to highlight that, mean of 70, standard deviation of 8. And the question is, which of the following choices correctly describes how to determine the proportion of men that have a pulse rate greater than 78? Okay, so the score of 78 is the score that we're interested in. And if we just graph this, and I always recommend drawing your normal curve and putting it in. So here in the middle we have 70, the value 78 up here is going to be exactly 1 sigma, 1 standard deviation to the right. And if the question wants us to identify the proportion of men that have a pulse rate greater than 78, that's going to be this area to the right here. And so we just, looking at the answers A, B, C, D, I can see that they're in Z-scores, right? So I have to figure out, well, the number 78, the X value that we've got, what is that Z-score compared to the mean of 70? And considering we have a standard deviation of 8, that means that it is 1 Z-score above the mean. So we're going to have to determine the area to the right. That's what I've highlighted in pink. So it's going to be B or C. The right of Z equals 1. So that's just going to be answer B. To the right of Z equals 1. Question 5. Question 5. The equation of the tangent to the curve f of t times e to the t at t equals 1 is what? Okay, if we're doing the equation of a tangent, we need to find the first derivative of this function. Now, this function is going to be a product rule. So we're going to have t equals u and v equals e to the t. So u dash here is going to be 1, v dash here is going to be e to the t again. So if I'm finding the derivative, or f dash of t, it's going to be uv dash plus u dash v, which is going to be u is t, v dash is e to the t, so that stays the same. And then u dash is 1, v is e to the t, so it's just plus another e to the t. It wants the equation of the tangent to the curve at t equals 1. So if we substitute t equals 1 into this equation, we get ourselves the gradient at that point, which is going to be part of the tangent. So then I'm just going to do f dash of 1. It's going to be 1 times e to the 1 plus e to the 1, which is just going to be 2e. So now I'm going to substitute that into the equation of a line. I've got y take y1 equals m bracket x take x1. I have not got a point on this curve, so I'm going to substitute t equals 1 into the original to find out the value at that point. So I'm just going to quickly go f of 1 is going to be equal to 1 times e to the 1, which is just going to be e. So therefore my y1 value is going to be e equals m, which is our gradient. We just found that, that's 2e. I'll just highlight that there. The gradient is going to be the m value. And then we've got x take x1, the value of x, which we've chosen, is 1. And we can just do some arithmetic here. Y minus e equals 2ex minus 2e. I'm going to add e, so I get y equals 2ex minus e. And that's going to be, oh, okay. I've just realized that the answers are all in t, and I've just switched it to being x, but it doesn't really matter. 2et minus e is the equation of the tangent. I've changed the variable, but it doesn't really matter. So all I'm saying is that this should be t and this should be t1. And then you carry on with t's. Question 6, let's move on. Okay, if the probability of a success in a Bernoulli trial is 0.3, what's the variance? Okay, a Bernoulli trial is a special type of binomial. The variance in a binomial distribution is np 1 minus p, but where this is a Bernoulli trial, so n is just always equal to 1. So we're just going to have p bracket 1 minus p, which is going to be 0.3 times 0.7, which is 3 7s are 21, so it's going to be 0.21, which is D. So you can see that sometimes these multiple choice questions are very fast. Sometimes they take a while. Question 7, moving on. The life expectancy in years of an electronic component can be represented by the probability density function of that. The probability that the component lasts between 1 and 10 years. So that's just going to be the integral between 1 and 10 of that probability density function. I'm just going to write 1 over x squared as x to the negative 2 to save myself a bit of time. Integrate that, raise the power, divide by the new power. We get negative 1 on x between 1 and 10. Just a quick step there, that becomes, oops, not e, that becomes x to the negative 1 divided by negative 1. The negative comes out the front, and the x to the negative 1 drops to the denominator. That's where I got negative 1 on x from. Substitute those values in, you get negative 1 on 10. Take away, use your brackets, negative 1 on 1. Okay, so that's going to be negative 1/10 plus 10 on 10. Okay, so 1 is equal to 10 on 10. If we're adding fractions, the 2 minuses become a plus. If I'm going to do that, I get 9/10. And that's going to be answer C, 0.9, 9/10. Sweet. So, cool. Let's move on to question 8. A test includes 6 multiple choice questions. Each question has 4 options for the answer if the answers are guessed. So if the answers are guessed and there's 4 options, then my p-value is going to be equal to 0.25 or a quarter. Just looking at the answers are decimals, so I'm going to use 0.25. Now the probability of getting at most 2 questions correct. So that's probability of at most 2 is going to be equal to the probability of x being less than or equal to 2. That's at most 2, which is going to be equal to the probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. And now I'm just going to look at the answers and see which one of those match. So first things first, A only has 2 options, so that's not it. C has 2 options, but they're subtracted. I don't think that's going to be it. Same with D. It's either going to be B or D. They have 3 options. So let's just check B. It seems like the most reasonable. X equaling 0 is going to be 6, 0, 0.25 to the 0, 0.75 to the 6. That one's all good. Then we've got this one, all good, all good. So this one, for example, is 2 wins, 4 losses, or 2 correct, 4 wrong. Yeah, so that seems like an appropriate answer. We're going to select B for this one. Notice all you really had to do was figure out what was the structure of the probability. And yeah, that's it. Question 9. Right, as soon as you see a fraction, right, and you've got x's on the numerator and denominator, and you're integrating, think log. The derivative of the denominator of x squared plus 2x is going to be equal to 2x plus 2. So if I had the integral of 2x plus 2 over x squared plus 2x, right, the derivative of the denominator is on the numerator. If that was the case, it would just be the natural log of the denominator, x squared plus 2x plus c. But unfortunately, I don't have that. I almost have that. My numerator is x plus 1, not 2x plus 2. So it's off by a factor of 2 essentially. So if I'm actually integrating x plus 1 over x squared plus 2x dx, I really want to be multiplying the numerator by 2. Because if I do that, it turns into this, which is super easy to integrate. But I can't just multiply something by 2, that's changing the question, but I can multiply by 1, which is changing the question in a different way. So if I'm timesing by 2, I can also times by a half, right? The 2 and the half, when you multiply them, they cancel out to be 1. So I'm allowed to do this, it's just changing the format of the question, not the value of the question. And hence, I can still integrate the integral like normal, and I'm just going to have a half out the front of ln of x squared plus 2x plus c. So that's going to be question C. And finally, question 10. So we have a lot of information here, got to rapidly read it. Types of material being tested, withholding temperatures, random selection, the results are shown. Okay, what's the question? An approximate 95% confidence interval, the material A will break or completely shown by this. What are the values of C and N? Okay, so we're looking for 95%, so that's 1.96, so we don't have to figure that out. We're looking for the probability that material A will break completely or show defects. So if we're doing this and we're trying to figure out C and N, this C value appears to be my p hat, my sample proportion, and my N is just my total number of trials, right? So N is N. So if I'm looking at material A, right, so this is material A, the total is 95. So N is going to be 95, so it's going to be A, B, or C. And the proportion break completely or show defects is going to be the sum of these two values, 25 and 35, which is going to be 60, but out of my total of 95. So that's going to be A, the value A. Is that question 10? That's question 10, and we're done. Hopefully that helps. I'm going to do multiple choice questions, and essentially I'm going to do every external exam question for 2020, 2021, and 2022 in preparation for 2023. So make sure you stick around. If you find this helpful, make sure you like the video. This is going to be in a big playlist, so probably over to the side on YouTube somewhere. You can just go straight away to the next video in the series where I do the tech free questions that are short response. So simple familiar, complex familiar, and complex unfamiliar. I will see you there.